asked in 2016 for 2 marks. So here we had to calculate the hysteresis loss and eddy current loss, and you have to write the ratio between both of them. So 400 volt 50 hertz supply of transformer was given, and it's three operating point is given in the problem. First operating point is 200 volt 25 hertz, and at that operating point iron loss is given 2 kilowatt. Another operating point is 416 volt 52 hertz, and at that operating point what will be the losses that we had to calculate. And the first operating point was 400 volt 50 hertz, and its iron loss was given 5 kilowatt. So any common thing, can you able to visualize any common factor among these three operating point, if you recall?
Hysteresis loss would be constant.
Yeah, this hysteresis
Uh,
loss would not be constant. That factor
Iron
would
losses.
be, that factor would be constant throughout. So why so? Whenever this mm, V by F ratio you might have heard. So if this is constant, then your factor KH and KE, which would contribute to KI, that would remain constant. Otherwise, this factor would come from the loss formula of pH and PI. Is anybody able to recall the expression of pH and PE?
yes, sir.
Yeah,
Yes, sir. P is equal to K A plus square BM square, sir.
if a square,
A,
no,
no, sir.
if,
A
okay,
only A, sir, and B M के power x.
okay, F and Bm raised to power x.
P is equal to K A plus square BM square.
K F square Bm square. And one factor, if I would recall clearly, thickness का square.
Yes, sir.
हाँ. And here also,
yes, sir. एक ऐसे भी डायरेक्ट कांस्टेंट लेके ये बोल सकते हैं कि पी आई इज इक्वल टू ए इंटू ए प्लस बी एफ स्क्वायर.
and Bm is proportional to V by F. So if you put this V by F in this expression in pH, KH F V by F raised to power x, right? So if V by X is constant, let's say, then whatever will be the ratio, that would be constant. So it will not matter if V by F is constant. So this would be insignificant during that time. If this ratio is not constant, then you have to take proper thing, and then a Steinmetz constant would come in picture. This X is generally varies from 1.6 to 2. And similarly, if Bm, if you put V by F ka square, then you can get it Ke F square, right? So I think some mistake is there. Ke Bm square.
सर कैन आई से सर.
Yeah, please go ahead. I actually simply.
सर यहाँ पर बी बाई एफ जो है दोनों केस में है कांस्टेंट है.
Huh.
तो
Okay,
जो भी
okay.
है.
Yeah, I got it. I got it. So if it is constant, it won't matter here, right? That's what you want to say?
यस सर, यस सर, यस सर.
So it will effectively vary with KEF square. So thanks. Actually, that's quite a long time since I revised it. So that's why you guys also keep revising all the things. So, but I remember that pH varies with frequency, KH times F, and P varies with F square, that is KEF square. So hence, if you go for the high speed thing or high frequency thing, uh, why frequency does matter in transformer? Because if you go for high frequency thing, your transformer will become a smaller and smaller. Same thing happens with motor or generator set. If you go for high speed motor, you see that your number of poles would get lower and your motor size would started to become smaller and smaller. So, but at the same times, your ED loss and hysteresis loss would also get added up. It would be significant. You see, it is varying with F square, so that is quite huge. And in motor, we try to, or in any machine, you try to take care because uh, it might not be, quantifiable to you, but generally in machine, if you go at higher speed, this iron losses become dominant compared to your copper loss. So that's why we use this lamination, this lamination thickness. So any motor would be laminated. That a stack gets laminated, single. So for that purpose, your thickness, this eddy current losses, that depends on T square. Why? Because the smaller the lamination thickness would be, the lesser would be your eddy current loss. So do you know how much the thickness of lamination generally we use for our silicon steel or kind of modern day? How much
2
lamination?
mm, sir.
2
1
mm,
mm, 2 mm
one
is
one
0.5.
1 mm, 2 mm. Okay,
0.2 mm,
point 2 mm. Yeah, you are quite close.
around
Point.
0.35 mm.
Yeah, 0.35 is very common. That is known as material M235 and or M19 as well. So 0.35 is very common. You can easily get in India. But nowadays, since very high power, very compact motors are required, very compact drivetrains are required, so the minimum lamination steel till date I have seen that thickness is 0.1 mm. And believe me, if I am going to design a motor for like 500 kilowatt or 600 kilowatt, it improves the efficiency from 92% to 97%. So 5% of efficiency in terms of hundreds of kilowatt, that is significant. So that kind of help this smaller laminations does in electrical machines. So that's I just wanted to quantify this concept. So it is very crucial in machines. This eddy losses and hysteresis losses. So moving ahead with the problem, the 3 points are given. So I can form three equations uh, based on pH is equal to KHF, P is equal to KEF square, and total iron loss, if I write, that would be sum of hysteresis and eddy, and I can write KHF plus KEF square, right? So I will write three equations since 3 points are given. So first was given 450 hertz and 5 kilowatt. So I can write 5000 watt is equal to KH into 50 plus KE into 50 ka square. If I will simplify it, so this KH plus uh, 50, so 50 by 100, 2 KE, I guess. Uh, but it is 50
ये
KE.
बोथ
20.
साइड डिवाइड कर देंगे सर 50
Yeah,
से।
yeah. You divide it with 50 on both sides. So you will get KH plus 50 KE. KH plus 50 KE is equal to 100. It is your first equation. And similarly, the second point is given. Let me show you. It is given at 25 hertz, 200 volts. So you can see the V by F is constant here. So that's why I am applying this direct KHF and KEF square. So 400 by 50. So that comes out to be 8. Okay, V by F ratio is 8. Let us check at 200 by 25. That would also come out to be 8. And at asking operating point 416 by 52, so that would also come out to be 8. So everywhere V by F is constant. So I will write another condition. So that's 2000 hertz, 2000 kilowatt is equal to KH into 25 frequency by 25 hertz plus ke into 25 ka square. So if you solve this equation, you will get kh plus 25 ke is equal to 80. So it will be your second equation. And if you solve this two equations, you will get kh equal to, 60. And
Yes,
ke, and ke,
0.0.
yeah. So ke is equal to 0.8. So you can see ke factor is less because it is dependent on f square. So ke should be quite less. So that's the thing here. And now we have asked to find out at 416 volt and 52 hertz. So we know kh at 52 hertz of frequency plus ki into 52 ka square, and I will put 60 at the place of kh, and I will put 0.8 at the place of k, and after solving you will get hysteresis loss component of 3120. This come out to be 3120, and this would come out to be 2163.2 watt. We were asked the ratio of hysteresis by AD. So this is hysteresis, this is AD. So pH by PE is equal to 3120 divided by 2163.2, and it is known as, okay, so I will see what is it. So its ratio would come out to be 1.4423.